GCSE Physics boosters, vectors and scalars. This is my first video for the forces topic, and it's all about vectors and scalars. Let's do it. So, look at these two lists of quantities. What is the difference between them? Well, mass, energy, distance, speed, temperature, volume, they are all examples of scalar quantities. Velocity, force, momentum, acceleration, field strength, weight, they are vectors. So the first list are scalars, the second list are vectors. What's the difference between them? And the answer is that vectors have something that scalars don't have. What's that? Well, scalars have got magnitude, and that basically means you can put a number on how much of it there is. So a mass of 20 kilograms, 20 joules of energy, 50 meters, 12 meters per second. You can give it a number to say how big it is. Now, vectors have magnitude as well, but vectors have direction. So a velocity of 7 meters per second north, a force of 100 newtons upwards, a momentum of 30 kilogram meters per second in the x direction, an acceleration of 9.8 meters per second downwards. They have direction. You couldn't say a mass of 20 kilograms upwards. That would just be nonsense. You know, a temperature of 30 degrees east is just daft. Scalars have magnitude, vectors have magnitude and direction. Okay, hopefully this will help. Consider this. Here's Joe, my mate Joe. Now, Joe walks from A to B, and B is 50 meters away. It's east. Okay, so Joe walks east 50 meters to get from A to B, and the total distance he walks is 150 meters because he's a bit daft. So he enjoys his exercise, and it takes him 100 seconds to do it. So consider this. What distance has he traveled? What is his average speed? I say average because he might speed up and slow down. I don't know. What's his average speed? What is his displacement at B? And what is his average velocity? Have a think. See if you reckon you know the answers. And the answers are, now, what distance has he traveled? Well, that's 150 meters. It doesn't matter what direction that's in. That is just the distance he has walked. He has walked 150 meters. What is his displacement at B? Well, it's 50 meters east. Okay, distance, or if you like, length, is a scalar quantity. Displacement is a vector quantity. And he has ended up 50 meters away from where he started in the easterly direction. His displacement is 50 meters east. His average speed is his distance traveled divided by time. So 150 divided by 100 is 1.5 meters per second. And again, speed is a scalar. It doesn't matter what direction he's walking in. His average speed is 1.5 meters per second. His average velocity is displacement over time. So that will be 50 divided by 100, which will be 0.5 meters per second east. Again, notice displacement and velocity are vectors. They have direction. Okay, distance and speed are scalars. Direction doesn't matter. Something else about vectors which is very useful, we can represent vectors with an arrow. We can draw an arrow. Because vectors have direction, we can represent the direction of the vector with an arrow. There's Joe walking at 0.5 meters per second in that direction. There's a bloke pushing a car with a force of 300 newtons that way. Look at the map. So Sedgefield is about 12 kilometers from Stockton in that direction. That guy is accelerating downwards at 10 meters per second squared, and there's an electric field, and the strength of the electric field 500 newtons per coulomb in that direction. Okay, we can represent vectors with an arrow, and we're going to be doing a lot of that in this topic. This topic is all about forces. Okay, we're going to be talking lots about forces. Here are some examples of forces. Thrust, if you have an engine, the force pushing it forward is called thrust. Friction always tries to slow things down. It either tries to stop it moving or it tries to slow it down. Friction opposes motion. Tension, if we stretch this spring, it pulls back. It has tension inside the spring, we say. Bottom left, if we put a cup on a table, then there's the weight of the cup pulling downwards. Weight always acts towards the center of the earth. Weight is basically the gravity due to the earth attracting objects with mass. So weight attracts downwards, it's pulling the cup downwards. What's stopping the cup going downwards is the push of the table. A posh name for that is the normal contact force. Normal just means at right angles. If you've done anything about optics and refraction, you should know that. So the normal contact force. And then the aeroplane, there's the weight of the aeroplane, and there's this force lift due to the wings. That's what the wings on an aeroplane do. If an aeroplane didn't have wings, it wouldn't be able to fly. To finish off this video, non-contact forces. Here are some examples of non-contact. Now, non-contact, as the name suggests, is when something experiences a force without touching something else. For example, this electrostatic force, this little positively charged ping pong ball, is being repelled because it's in this electric field. The force due to gravity is a non-contact force. The Earth, the mass of the Earth is pulling this fella down. The force due to gravity is called weight, and it's a non-contact force. And then these two magnets attracting each other, and that's another example of a non-contact force. So what have we got from this video? What's the difference between a vector and a scalar quantity? Give 3 examples of each. How can we represent vectors on paper? What is a non-contact force? And if you don't know them, look at the video again.